Hello, students. I am Dr. P. Revati, and I conduct online and offline classes for GATE preparation for ECE students and also other subject preparation related to electronics and communication engineering and computer science engineering also. Besides that, I also handle class 10th, 11th, and 12th CBSE physics online offline classes. Kindly contact for any classes. Yes, today we'll see about basic diode introduction, concepts, application of diodes, and then certain equations. We'll derive some equation for diode large signal model. Okay, and these are large signal model analysis equations like diode's current equation, what is the mean square voltage equation for DC and AC voltage in a diode. All these questions are important. So first of all, we'll see the introduction part of the diode, and then we'll go to the derivation part. So, so diode, it is the simplest and most fundamental nonlinear circuit element. So it has got two terminals. One is an anode and cathode, and it is where it is applied. It will be used in rectifier circuits like half wave rectifier, full wave bridge rectifier circuits. So these are the applications where they are used in these diodes. So this is a physical structure of a diode. So this diode is made up of P and N type materials, and the P and N junction together is said to be the diode. This P type is actually made up of silicon, and we call this P type as anode, and another N type which is made up of silicon, depending upon the doping, it is called as an cathode. Okay, so this anode and cathode are P and N type semiconductor materials, and they form the physical structure of a diode. Then it is an electrical device. It acts as a switch. We know the diode. We are using diode to act as a switch. So this diode will allow the current to pass only in one direction. It will allow the current to flow in only one direction. So the applied voltage to the semiconductor diode is referred to the bias voltage. What is the voltage called as? We call it to be the bias voltage. There are two types of bias voltages which can be applied to the diode. One is going to be the forward bias voltage, and another one is said to be the reverse biased voltage. Okay, so there are two types of bias voltages. One is forward bias, another one is the reverse bias. So here we can see in forward biased, how will the PN junction diode work? So in a forward bias condition, you can see this image, the figure. Okay, so you can see the image, the P and N type, how they are connected to the source voltage Vs. There is a source voltage and how they are connected. The P type is connected to the positive, and the N type material is connected to the negative of the voltage supply. Okay, so automatically the how the forward bias is made. There is an external electric field formed, and the positive terminal of the battery connected to the P type, and negative terminal of the battery is connected with the N type. This is the basic thing needed to start a diode in the forward biased condition. So now the current starts flowing. The maximum current will be flowing through the diode during the forward biased condition. Okay, in the reverse bias condition, if we are going to change the connection of the source voltage, like the P type to be connected to the negative part of the voltage supply and N type to the positive part, what happens then? There will be no current flowing. It will come to the reverse bias condition. Okay, so you can see here also in the forward bias condition, the depletion region, that is the junction region between the P and N type material. You can see that it is small. The depletion region, it is very small. Therefore, it is going to be in the forward biased. It is allowing the electrons and holes to combine together, and it is allowing the current to pass through this material. Suppose if the depletion region is high, that is in the reverse bias condition, the depletion region will be very high. It will block the flow of the current or the passing of holes and electrons. Therefore, there will be no flow of current. That is the difference between the forward bias and reverse bias. In the forward bias, you can see that the depletion region formed is very small. Okay.
And the reverse
And the
bias
reverse
condition, you
bias
can see
condition,
the
you can see the
depletion region,
depletion
it is
region,
high.
it is high.
Okay, only there
Okay,
will be
only there will
the
be
flow of
the
current
flow
due
of
to the
current due to the
minority charge
minority
carriers.
charge
Minority
carriers.
charge
Minority
carriers
charge
are
carriers are
holes, and
the
because of
holes, and because
holes
of
only,
holes
there
only,
will
here
be
will be
flow
flow
of
of current
current
during
during
the
the reverse
reverse
bias
bias
condition.
condition.
So you can
So
see,
you can
also
see
see
also
that in the
see
reverse
that in the
bias
reverse
condition,
bias
in the
condition in the
voltage Vs,
voltage
the source
Vs, the
voltage,
source
the negative
voltage, the
part,
negative part,
negative
negative
terminal is
terminal
connected
is
to the
connected to the
p-type
p-type
semiconducter, and
semiconductor, and
the positive
the
terminal of the
positive terminal
voltage
of
is
the voltage
connected
is
to the
connected to the
n-type
n-type
semiconductor material.
semiconductor
That is
material.
why the
That is why
depletion
the
region
depletion
is
region is
increasing.
increasing.
Depletion
Okay,
region, how
depletion
it
region,
increases?
how it
Because
increases?
the
Because
positive
the
voltage is
positive
connected
voltage
to
is
the
connected to
n-type
the n-type
semiconductor material.
semiconductor material.
Automatically,
Automatically, it
attracts the
attracts the
electrons towards
electrons
the
towards
positive
the
type.
positive type.
Similarly,
Similarly,
the p-type is
the p-type
connected
is
to the
connected to the
negative half
negative
of the
of half
negative
of the
part of
negative part
the
of the
voltage.
voltage.
Therefore, what
Therefore,
happens
what
here? Also, the
happens here?
holes
Also,
are
the holes
attracted
are
towards
attracted
the
towards the
negative
negative
voltage
voltage
terminal. That is
terminal.
why the
That is why
depletion
the
region
depletion
formed is
region
very
formed
high.
is very high.
This
This
At
at
this
this
condition,
condition, there will be no current
there will be
flow.
no
There will
current
be
flow
no
into
current
the
flowing
p
through
and
the
n type
p and n type
semiconductor,
semiconductor,
and we say
and we
that the
say
diode
that
is
the
in the
diode is in the
reverse bias
reverse
condition.
bias condition.
Okay, we say
Okay,
that
we
the
say that the
diode is in the
diode is
reverse
in the
bias
reverse bias
condition.
condition.
Okay.
Okay.
So what is the
So
Zener
what
and
is the Zener
avalanche
and
breakdown?
avalanche
We'll be
breakdown?
seeing
We'll be
it
seeing it
when we are seeing
when we are
about the
seeing
Zener
about the Zener
diode.
diode.
So at a
Okay. So
particular
at a
point in the
particular
reverse
point in the
bias
reverse bias
condition, when we are
condition,
setting
when
up
we
a
are setting up a
voltage,
voltage,
a cut-in
a
voltage
cut-in
where
voltage, where
after passing
after
that
passing
cut-in
that
voltage,
cut-in voltage,
the current
the
becomes
current
very
becomes
high,
very high,
and the diode
and the
starts to
diode
conduct.
starts to
That is said
conduct.
to be
That
a
is said to
Zener
be a
diode.
Zener
We'll
diode.
be seeing
We'll
it
be seeing it
when we
when
complete
we
this
complete
PN
this
junction
PN
diode.
junction diode.
So here you
So
are
here you
seeing
are
the types
seeing
of
the types of
diodes.
diodes.
There are
There
four
are
types of
four types
diodes.
of
What is
diodes.
first one is a
First
PN
one is a
junction
PN
diode.
junction
Just now we
diode.
saw
Just now
how
we
it
saw how
works.
it works.
And
And
second one is
second
the
one is the
LED,
LED,
light emitting
light
diode.
emitting diode,
And you can see
and you
the
can see the
image. And
image, and
photodiode, which
photodiode, which
works when you
works when
apply
you
some
apply
light on
some
the
light on the
portion
portion
of
of
anode
anode
and
and
cathode. Then
cathode.
the
Then the
Zener diode,
Zener
and you can
diode,
see
and
the
you can
image, how
see the
it
image
looks
how
like.
it looks like.
So these are the
So these
four
are the
types
four
of
types
diode,
of
and we are
diode,
going to
and we are
see
going to see
at what
at what
region,
region, at
at
what
this
type of
diode will
this
start to
diode will
work.
start
We
to
saw
work.
that in
We
a
saw
PN
that in the
junction
PN
diode,
junction
when
diode,
you supply
when you
the
supply the
voltage supply
voltage supply
properly,
properly,
automatically when the
automatically
positive
when
is
the
connected to
positive
the
is
p
connected
type
to
and
the p
negative
type
to the
and
n
negative to
type,
the
the
n type,
PN
the
junction
PN
diode will
junction
start to
diode will
work in
start to
the
work in the
forward bias
forward
condition.
biased condition.
Similarly, the LED,
Similarly, the LED
photodiode
photodiode and xenodiode
have its
have
their
its
own
their
working
own working
principles. We'll be
principles.
seeing
We'll be
them one
seeing
by
them one by one.
Okay, so
Okay, so
the first one
the
PN
first one
junction
PN
diode,
junction diode, as
we have
we
seen the
have seen the
forward bias and
forward
reverse
biased and
bias
reverse bias
condition.
condition.
It is
It is
repeated here. It is
repeated
a
here. It is a
one-way
one
valve. It
way
is called
valve.
as
It
an
is called as
one-way
an
valve
one way
because
valve
it
because
conducts
it
only in
conducts
one
only in
positive
one
half.
positive half. Otherwise,
Otherwise
it remains
open
open
circuited.
circuited.
Okay, so
Okay, so
when the positive
when the
voltage is
positive
applied
voltage
to
is
the
applied
p
to
I
the
junction
didn't
p
diode,
understand this way.
what ma?
what ma?
I didn't understand this way.
So
So
should I
how do you should I
explain?
explain?
Some pictures and some points.
Yes, we have
Yes, we
pictures
have
here.
pictures here.
We'll be seeing it
We'll be
in the
seeing it in the
slide. This is
Hmm.
enough.
slide. This is enough.
Yes.
Okay, so
Okay, so this
this
one,
part don't
this
worry
part,
about.
don't
These are
worry
all
about.
the
These are all the just the
summative points,
summative
just
points,
introduction
just
points
introduction
about
points
what
about
is an
what
LED
is an
diode, what
LED
is a
diode, what is a
photodiode. We'll be
photodiode.
seeing
We'll be
them
seeing them
individually, one
individually,
by one.
one by one.
Don't worry.
So don't worry.
Oh,
Okay.
okay.
LED
Lead
semiconductor, two
semiconductor,
lead.
two lead.
Let
There will be
There will
two
be
let
two lead.
two LEDs
Two
like this.
leads like
You can
this.
see
Like
an
you can
anode and
see an
cathode
anode and
connected
cathode
here.
connected here.
This part.
This part.
let semiconductor means what?
It is
It
not
is not
a
a
lead.
lead.
It is a
It
lead.
is
That
a
is
lead. That is
there will be two
there will be
pins for
two pins
connection. See,
for
I will
connection.
show
See, I
you.
will show you.
Can you see here
Can you
two
see here
pins?
two pins?
One pin,
Here
and
one
then here
pin, and
another
then
pin.
here another pin.
So this will be
So
used
this
for
will be used
connecting,
for connecting,
Hmm.
and hence it is
and
called
hence
as
it is called
a
as a lead. Okay.
Oh, this is lead.
yeah.
Yeah.
Oh, okay.
Then
Then
so
So
You can
you
see
can
here the
see
for
here the for
FWB means nothing
FWB
but
is
the
nothing but
forward
the
biased
forward
region,
biased
and
region, and
RWB is the
RWB
reverse
is the
biased
reverse
region.
biased region.
And you can see
And you
here
can
in the
see
forward
here in a
biased
forward
region
biased
the
region, the
curve, that is
curve,
when
that
we
is
increase
when
the
we
voltage
increase
the
the
current
voltage, the
starts to
current
flow.
starts to
It is
flow.
shown
It
here.
is shown
And
here.
in the reverse
And in the
biased
reverse bias
condition, what
condition,
happens
what
here?
happens here?
You can see
You
here in
can
the
see
reverse
here in the
bias
reverse
condition
bias
there is no
condition, there
current
is
flow,
no
only
current
there
flow,
is a
only there
leakage
is a
current
leakage
flowing
current
here.
flowing here.
And when the
And when the
voltage
voltage
crosses a
crosses a
particular voltage
voltage,
which
which
is
is
called
called
the
as the
zener
Zener
voltage,
voltage,
Z is
V
said
Z
to be
is
the
said
zener
to be the
voltage.
Zener voltage.
And
And when the voltage is going to cross this particular voltage, the
what happens,
what happens?
current
The
flows very
current
high
flows
here.
very high here.
And this point
And
is
this
said to be
point is
the
said to be the
breakdown
breakdown
region, where
region, where when the voltage, reverse voltage is
cross the
going to
particular
cross a
zener
particular
voltage,
Zener
the
voltage,
diode
the
starts to
diode starts
operate
to
in the
operate
reverse
in the
bias
reverse
condition.
bias
And
condition.
this is going to
And this
be
is
the
going to be the
VI
VI
characteristics of the
characteristics
zener
of the
diode,
Zener diode, voltage current
characteristics of the
characteristics of the
zener diode.
Zener diode.
So you can see
So you can
the
see
theory
the
part. When
theory part.
reverse
When
bias
reverse
voltage
bias
applied
voltage
to the
applied
zener
to the
diode,
Zener diode, it reaches the Zener voltage. It starts allowing large amount of electric current here, because we know
the
that
zener
the
diode is
Zener diode
heavily
is
doped.
heavily doped.
Okay, so the
Okay, so the
depletion region will
depletion
be very
region will be
small,
very
and it
small,
allows
and it
more
allows
current to
more current
flow
to
through.
flow through.
Okay, so this is
Okay,
the
so this
VI
is the VI
characteristics of the
characteristics of the
zener diode.
Zener diode.
Then
Then
the zener
the
breakdown, how
Zener
does it
breakdown, how
happen?
does it
It
happen?
happens
It
depending
happens
upon the
depending upon
amount
the
of
amount
doping,
of
how
doping,
we
how
prepare the
we prepare the
semiconductor material.
semiconductor material.
Depending upon the
Depending
amount
upon
of
the
doping
amount of
applied,
doping
the zener
applied, the
breakdown
Zener
voltage,
breakdown
the
voltage, the volt
VZ will be
VZ will
framed
be
there.
framed there.
And if the
And if the
diode is heavily
diode is
doped,
heavily
we know
doped, then
that
we know that
breakdown will occur
breakdown
at
will
the
occur
low
at the
reverse
low
voltage
reverse
itself.
voltage
Low
itself.
reverse
Low
voltage
reverse voltage na
when we
enartham?
start
When we
increasing
start
the reverse
increasing the reverse
voltage at
voltage
an earlier
at an
stage
earlier
itself,
stage itself, if the
doping is very
doping is
high, then
very
the
high,
zener
then the
breakdown
Zener
will happen.
breakdown will happen.
Suppose
Suppose if the
doping is
doping is
light,
light,
only we have
only we have
applied little
applied a
doping,
little
then we
doping,
have to
then we
increase
have to
the reverse
increase the
voltage
reverse
little bit,
voltage a little bit,
then only the
then
zener
only the
breakdown will
Zener breakdown
happen.
will
So
happen.
one point you
So
can
one point you can
in mind,
keep in mind,
that is the
that is,
diode
if
is
the diode
heavily
is
doped,
heavily
then there
doped,
will
then
be
there will be Zener
occurring
breakdown
at
occurring
low
at
reverse
low reverse
voltages.
voltages.
And where it is
And where it
applied,
is
the
applied, the
zener
diode, where we
apply
are going
this
to apply this
zener diode in
Zener diode in
applications, it will be
applications, it
used
will
in
be
voltage
used in voltage
stabilizers
stabilizers
to stabilize
to
the
stabilize
voltage.
the
Okay,
voltage. Okay,
so it will be
so
used
it will
in
be used
voltage
in the voltage
stabilizers and
stabilizers,
also
and also in
shunt
shunt
regulators. Shunt
regulators. The
regulators
shunt
are nothing
regulators
but
are nothing
parallel
but parallel
regulators. Okay,
regulators.
so
Okay,
zener
so
diodes are
Zener
used in
diodes are
voltage
used in voltage
stabilizers and
stabilizers
shunt
and shunt
regulators.
regulators.
Hmm.
And
And
applications of diode,
applications of
all the
diode,
four
all
types
the
of
four
diodes we
types of
have seen.
diodes
We
we
have
have
seen
seen. We have seen
PN junction
PN
diode, then
junction
we have
diode,
seen
then we
the
have seen the
photodiode,
photodiode,
and then
LED,
xeno
and
diode
then
also,
xenodiode also,
where we can
where
apply
we
these
can
diode
apply these
circuits.
diode
We can
circuits.
apply
We
them
can
in the
apply them in
rectifier
the rectifier
circuits.
circuits.
That is where
That
the
is
AC
where the
voltage will
AC
be
voltage will be
converted to DC.
converted to DC.
Okay, so we
Okay,
can apply
so we
them
can
in the
apply them in the
rectifier
rectifier
circuits and also
circuits
in
and
clipper
also in
clamper
clipper clamper
circuits.
circuits.
Okay, in
Okay,
rectifier
in
circuit,
rectifier
we'll be
circuit,
seeing
we'll be
what is a
seeing
half
what
wave
is a half
rectifier,
wave rectifier,
what is a full
what
wave
is a full wave
rectifier, and
rectifier,
also
and also
bridge
bridge
rectifier
rectifier
circuits. We'll be
circuits.
seeing
We'll
them
be
in
seeing them
detail
in
one by
detail one
one.
by one.
So, what
So,
is a
what is a
rectifier?
rectifier?
We are going to
Actually, we
see
are
an
going to see
introduction
an
part of
introduction
what is
part
a
of what is a
rectifier
rectifier and how half wave
and
and
full
full
wave
wave
is going to
rectifier is
work.
going
We
to
are going
work.
to
We
first
are going to first
see the
initially see the
working principle.
working principle.
Once we are thorough
Once
with
we
the
are
working
thorough with the
principle,
working
then
principle,
we
then
are going to
we are
derive
going to
for the
derive
diode
for the
current
diode
equation.
current
What is going
equation.
to be
What
the
is
root
going to
means
be the
per
root means
voltage?
per
We are
voltage?
going to
We are going to
derive the
derive the
part.
part.
Okay, so first we
Okay,
are
so
going to
first
see
we are
the
going to see the
introduction part, that is
introduction
the
part. That
theory
is the
part
theory
about the
part about the
rectifiers, where you can
rectifiers,
see
where you can see
how it
how
works.
it
You will get a
works. You will
basic
get a
knowledge
basic
about
knowledge
how a
about how
half
a
wave rectifier
half
is
wave
going to
rectifier
work,
is
how
going
a
to
full
work,
wave
how
is
a
going
full
to
wave
work.
is going to work.
Then we'll go into
Then
the
we'll go into the
derivation part.
derivation part.
Okay,
Okay.
so you can see
So you can
here
see here
a rectifier
a
is a
rectifier is a
device
device
which
which
converts
converts
AC into
AC
DC.
into
That is the
DC. That is a
alternating current
alternating
into a
current
direct
into a
current.
direct
That is
current.
the
That is the
main purpose of
main
a
purpose of
rectifier.
a rectifier.
Okay, an
Okay.
AC
An
current will
AC
have
current will
both
have
a
both a
positive voltage and
positive voltage and negative voltage, where the average voltage will be equal to zero. We are going to convert a alternating current into a direct current. Okay, and this process is called as rectification. Okay, so first of all, we learn about a half wave rectifier. It is a simplest form, and we are going to use only one diode here in the circuit to perform the half wave rectification, because normally a diode works in the forward bias condition and does not conduct in the reverse bias condition. So this half wave rectification can be reached by only using single diode, one diode. Okay, so
So
how
how
does
does
it
it
work?
work?
You
You
can
can
see
see here,
here
their
their
diagram
diagram
is
is
given,
given,
and
here you can see a diode, a single diode,
and
and
a
a
source voltage
source
is
voltage is
connected. The
connected.
source
The
voltage
source voltage positive is
to the
connected to
anode,
the anode,
and negative is
and negative
connected
is
to the
connected to
cathode.
the cathode.
Okay, and
Okay,
at the
and
output
at the
end you have
output end
got
you have got an
RL,
RL,
the
nothing
load
but a
resistor.
load resistor.
To measure the
To measure
output,
the
we are
output, what
using
we are using, we are going to use a
load resistor,
load
and the
resistor,
voltage
and the
across the
voltage
load
across the
resistor
load
will be the
resistor will be
output
the output
voltage.
voltage.
And what is
And
the current
what is the
inputs
current
here? They have
inputs here?
shown
They
an
have shown an
alternating symbol, a
alternating
sine
symbol, a
waveform
sine
symbol.
waveform
It
symbol.
shows
It
that it is
shows
a
that
sine
it is a
waveform,
sine
that is an
waveform, that is an
alternating current which
alternating
is
current
used
which
in
is
the
used
input
in the
current.
input current.
So what we
So
know,
what we know, we have
about a
learnt
PN
about a
junction
PN
diode.
junction diode.
How does it
What
work?
how does
It
it work?
works such
It
that
works such that
when a
even
positive
a positive
voltage is connected
voltage
to
is
the
connected to
anode
the
and
anode
negative
and
voltage to the
negative voltage to the
cathode,
cathode, this
starts
diode
working in
starts
the
working
forward
in the
bias
forward
condition.
bias
Yeah.
condition. Yeah.
So an
So an
alternating current will
alternating
have
current will have
both the
both
positive
the
half
positive
and the
half
negative
and the
half.
negative half.
An
An
alternating current will
alternating
have,
current
this
will
is an
have, this is going to
input
be the
current
input
now.
current
It
now.
will have a
It will
positive
have a
voltage
positive
and also
voltage
a
and
negative
also a
voltage.
negative
This
voltage.
complete
This
cycle is
complete
said to be
cycle is said to
one
be
cycle.
one cycle.
Yeah, one
Yeah,
cycle
one cycle
of a
of
applied
a
voltage.
applied
This is an
voltage. This
input
is the
AC
input AC
voltage,
voltage,
alternating current.
alternating current.
And you can see
And you
here,
can
this is
see
the
here, this
input.
is the input.
So this has
So
got
this
two
has got
cycles.
two cycles.
From 0 to
From
pi,
0 to
there is
pi,
going to be a
there is going to
positive
be a
cycle.
positive cycle.
Then from pi
Then
to
from
2
pi
pi,
to
there
2
is going
pi,
to
there
be a
is going to
negative
be a
half
negative
cycle.
half
And this
cycle. And
voltage is
this
a
voltage
positive
is a
voltage.
positive
And
voltage.
here you will
And
get a
here you will
negative
get a
voltage. This
negative
is
voltage.
V.
This is V.
Okay.
Okay.
So
So
this is going to be
this is
time
going to be
period in
time period
seconds.
in
Time in
seconds. Time in
seconds. So
seconds.
this is going
So
to be
this
the
is going to
input
be
which
the
is going to
input
be
which is
applied
going
to
to
the
be
half
applied to
wave
the half wave
rectifier. This
rectifier.
half wave
This half
rectifier
wave
is made up
rectifier
of
is
a
made up
PN
of a
junction
PN
diode.
junction diode.
It works
It
in the
works in
positive
the
half
positive half
direction. That
direction.
is,
That is,
when this
when
positive
this
half
positive
input is
half
applied
input
up
is
to
applied
this,
up to this,
the positive
the
half
positive of
input is applied
input is
here,
applied here,
this diode
this
starts
diode
to
starts
conduct.
to
It
conduct.
starts to
It
work
starts
as
to
a
work
short
as a
circuit,
short circuit,
and it will
and it
allow
will
the current
allow
to
the
pass
current to
through.
pass through.
It will allow the
It will
current
allow
to
the
pass
current
through
to
the
pass
circuit.
through the circuit.
Okay, there will be an
Okay, there will
output
be an
voltage,
output voltage.
will be
Will be
generated in the
generated in
output.
the output.
Okay, so
Okay,
at what
so at
happens at the
what happens
negative
at the
half of the
negative half
cycle?
of the
This part,
cycle? This part,
negative half of the
negative
cycle,
half
when
of
you
the
are going
cycle,
to
when you are
apply,
going to apply,
this
automatically
diode will
this
become
diode
as
will
a
become as a
open circuit.
open
It will
circuit. It
become as a
will
open
become as a
circuit
open
in the
circuit in the
reverse
reverse
biased condition.
biased
Okay, at
condition.
the
Okay,
forward
at the
bias,
forward bias, it will
in
be
the
in the
it will working
it
as
will
a
be working
short
as a
circuit.
short
Okay,
circuit.
so
Okay,
in the
so
negative
in the
half,
negative
what
half,
happens
what happens
automatically?
automatically?
This diode
This
will not
diode will
work in the
not work.
negative
In the
half. It will
negative
not
half, it
work.
will
So
not
what will
work.
be the
So what will be
output?
the
How
output?
can we
How
draw the
can we
output
draw the
voltage?
output
In
voltage?
the output
In the
voltage,
output
there will
voltage,
be
there will
output
be
present
output
here
present here
only for the
only for
positive
the
half,
positive
and
half,
for the
and
negative
for the
half, it will
negative
be
half, it
working
will
as a
be
open
working as a
circuit. There
open
will be no
circuit. There will be
output
no
present.
output present.
Okay, so
Okay, so
corresponding to this,
corresponding to
there
this,
will be an
there will
output
be an
generated
output
for the
generated
positive
for the
half
positive
only,
half only,
and in the negative
and in
half
the negative
direction, the
half
diode will
direction, the
not
diode will
work.
not work.
It will
It
behave
will
as an open
behave as an
circuit in
open
this
circuit
part.
in
It will
this
behave
part. It
as a
will
short
behave as a
circuit in
short
this part.
circuit in this part.
So we can
So
see
we
here
can
an
see here an
alternating current is
alternating current
converted
is
into a
converted
DC
into a
current,
DC
direct
current,
current here.
direct
Only
current
one
here.
half
Only
is
one
going to
half
be
is going to be
given as an
given
output.
as an
Okay,
output.
it is going to
Okay,
be
it
a
is going to
direct
be a
current.
direct current here.
So this working
So this
principle
working
is the working
principle is the
principle
working
of a
principle of a
half wave
half wave
rectifier.
rectifier.
Okay, when the
Okay,
voltage
when
is
the
a
voltage is
AC
a
positive,
AC
the diode
positive, the
becomes
diode
forward
becomes
biased,
forward biased,
current flows
current
through it.
flows through it.
When the voltage
When
is
the voltage
negative,
is
diode is
negative,
going to be
diode is
reverse
going to be
biased,
reversed
and the
biased,
current
and
will
the current will
stop flowing
stop
there,
flowing
and
there,
the circuit
and
will
the
behave
circuit
as
will
a
behave
open
as a
circuit.
open circuit.
Okay,
Okay,
this is the working
this is the
principle of
working
a half
principle of
wave
a half wave
rectifier,
rectifier,
and you can see
and you
here
can see
full wave
here full wave
rectifier.
rectifier.
How a full
How
wave
a full
rectifier is
wave
going to
rectifier is
work.
going to work.
So when we
So
need
when we
the
need
output
the output
for
for
a
an
half
half
wave
wave
rectifier,
rectifier,
the
the
output
output
current was
current was
only
only conducting in the positive half the cycle. Other half cycle there was no output இல்லையா அதுதான் வந்து half wave rectification. In a full wave rectification we can see here this is a full wave rectifier output. You can see here both the positive half during the positive half cycle and the negative half cycle we are getting the output waveform. That is we are going to get more voltage. Okay, that is we are going to get a higher DC value. Okay, well, the DC output voltage will be high in a full wave rectification. How it is possible? How it is possible? We are going to do, we are going to connect two diodes here, diode D1 and D2. Input is the same. We are going to apply an alternating current. And suppose the input signal is very high, that is a normal signal coming into the into a transformer with 220 volt. Then we are stepping down the 220 volt into a smaller winding as a secondary winding here. So here we are using a center tap. This
Ma'am, I
what is
didn't understand the 220. Thing.
Okay.
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 Now we'll
Now
go
we'll
into the
go
working
into the
principle of a
working
full
principle
wave
of a full
rectifier.
wave
A full wave
rectifier. A full
rectifier,
wave
we need
rectifier, we need
the output
the output
waveform. We are going to
waveform.
get
We
a
are going getting
complete
a complete
cycle
cycle
at the
at the
output.
output. Both the
Both the
positive
positive
half
half
and
and
the
the negative
negative
half
half
is
is
coming
coming
as
as
an
an
output.
output.
So how we are
So
going to
how we are
achieve
going to
that?
achieve
By
that?
using
By
two
using
diodes, I
two
said you,
diodes, I
diode
said you
D1,
diode D1 and D2,
and this is going to
and
be
this
the
is going to
center
be the
tapping.
center
This
tapping.
center
This
tapping
center tapping will
the input
the
will
input
what
will
happen? It
what
will
happen? It will
provide the
provide the
signal both
signal
in the
both in
positive
the
half
positive
and
half
the negative
and the
half
negative half
to the
to the
circuit.
circuit.
Okay, this
Okay,
center
this
tapping
center
will
tapping
allow
will
the
allow
positive
the
half cycle
positive
to
of cycle
flow
to flow
in this
in this
Hmm.
direction,
direction
in
in
this
this
way,
way,
and
and
in
in
that
that
condition
condition
diode
diode
D1
D1
will
will
start
start
to
to
conduct.
conduct.
And
And
also in the
also in
negative
the negative
half of the
half
cycle,
of the cycle
alternating current,
alternating current,
this
this
diode D2
diode
will start
D2 will
working
start
because
working
this
because this
negative half of the
negative
voltage
half
is
of the voltage
supplied
is
here,
supplied here,
and this will
and
start
this will
working.
start working.
This diode
This
D2 will
diode
start
D2 will
working in
start
the
working in the
reverse bias
reverse
Ma'am,
condition.
bias condition.
ma'am, please
Okay,
Then it will be correct
then it will
only.
be correct only. No
Okay,
problem. Okay,
Hmm.
so
so
see
see
the
the
graph.
graph. When
Draw
we
the graph
draw the
here in the
graph here
forward
in the
bias
forward bias
condition.
condition,
Diode will be
diode will
conducting
be
in this
conducting
way.
in this way.
This is nothing
This
but
is
the
nothing but the
threshold
threshold
voltage V
voltage V
V
V
Okay,
eta.
this is
Okay,
V
this
eta,
is V
nothing but
eta,
a
nothing but a
cut-in voltage. We
cut-in
call
voltage. We
this as a
call this as
cut-in
a cut-in
voltage.
voltage.
I'll explain you
I'll
what is a
explain you
cut-in
what is a
voltage
cut-in
also.
voltage also.
Then
Then
at reverse
at
bias
reverse
condition,
bias
there will be
condition, there will
only
be
a
only a
portion of
portion
current
of
flowing
current
in the
flowing
reverse
in the
bias
reverse
condition.
bias condition.
Okay, like we call
Okay,
this
like
as a
we call this
leakage
as a
current
leakage
or
current
I
or
naught.
I naught.
We call this
We
as
call
I
this as
naught.
I naught.
I naught we
I
can call
naught
it
we
as
can
a
call it as
reverse
a reverse
saturation current.
saturation current.
Reverse
Reverse
saturation
saturation
current
current
or leakage
or
current. We
leakage
call it
current.
as
We call
a
it
reverse
as a
saturation
reverse
current or
saturation
a
current or a
leakage current.
leakage current.
Then
Then
now we can
now
write
we
down
can
the
write down the
direct current
direct current
equation. Okay,
equation.
direct
Okay,
current
direct
equation or
current
the
equation or
diode
the
current
diode
equation.
current
Both are
equation.
the
Both
same.
are the
I
same.
will write
I
down
will
the
write down
direct
the
current
direct current
equation.
equation.
We take
To
down the
take
direct
down the
current
direct current
equation is very
equation is very
important.
important.
Direct
Direct
current
current
equation of
equation
diode
of diode
is given
is
by
given by
Diode
ID,
current.
diode
ID
current.
is equal
ID is
to I
equal
naught.
to
I
I
naught is
naught.
the
I naught
leakage
is the
current or
leakage
the
current or the
reverse
reverse
saturation current
saturation current
multiplied by
multiplied by
power
E power
VD, that is the
VD,
voltage
that is the
across the
voltage
diode,
across the diode,
divided by
divided by
eta. Eta, what
eta.
is
Eta, what is
eta? Eta is
eta?
nothing but
Eta
the
is nothing but
ideality
the
factor
ideality factor
multiplied by
multiplied by
VT
VT
minus 1.
minus 1.
This
This
is
is
the
this is the
equation of the
equation of the
diode,
diode,
current in the diode.
current in the diode.
Okay, but this is the
Okay, but
direct
this is the
current
direct
equation.
current
I naught
equation.
is
I
nothing
naught is
but it
nothing
is
but
the
it is the
reverse bias
reverse
current.
bias
E power
current. E
VD
power
is the
VD is the
voltage across the
voltage
diode.
across the diode.
Eta is the
Eta is the
ideality factor.
ideality factor.
Eta is the
Eta is the
ideality factor,
ideality factor,
which is going to
which is
range
going to
from
range
1
from 1
to 2.
to
This
2.
ideality
This
factor is
ideality factor is having
a range from
a
1
range
to
from 1
2.
to 2.
And V eta
And
is
V
nothing
eta is
but
nothing but
cut in
cut in
voltage.
voltage.
So this is for
So
a
this is for a this is
graph
the
IV
graph IV
characteristics of a
characteristics of
diode,
a diode,
which is made up
which
of
is made
either
up of either
silicon or
silicon or
germanium, and
germanium,
this
and this
V eta
V
is
eta
going to
is going
depend
to
upon
depend
the
upon the
semiconductor
semiconductor
material
material
out of which
out
the
of which the
diode is made.
diode is made.
If the
If the
material is going to
material
be
is going to be
silicon,
silicon,
if the diode is
if
made
the
up of
diode is made up of
silicon,
silicon, if it is a silicon diode,
then the
then
V
the
eta
V
will
eta
be
will
equal
be
to
equal
zero
to
point
zero
0.7. That
point
is the
0.7. That is the
PN junction
PN
diode will
junction
start
diode will
working
start
only at
working
this
only at this
voltage
voltage
0.7 volt.
0.7 volt.
If it is going to
If
be
it
made
is
up
going
of
to be made up of
germanium diode,
germanium diode,
then this V
then
eta
this
value
V
will be
eta
equal
value will be
to
equal to
0.3. At
0.3. At
0.3 volt
0.3
itself,
volt
the
itself,
diode will
the
start
diode will
working in the
start to
forward
work in the
bias
forward
condition.
bias condition.
Okay,
Okay.
so when
So
we want to
when we
draw
want
an
to draw an
ideal
ideal
IV
IV
characteristics,
characteristics.
so this is
So this is
normally
normally
set for
set for a
germanium diode
germanium
or a
diode or a
silicon diode. The
silicon
IV
diode. The IV
characteristics will be in
characteristics
this
will be in
condition.
this
That is at
condition. That is
V
at
eta
V
only.
eta
The
only.
diode will
The
start
diode will start
conduction. So up to
conduction.
that
So
there
up
will
to
be
that there will
only
be
a medium
only a
current
medium
flowing, and
current
after
flowing, and
V
after
eta the
V
current will
eta
be
the
very
current will
high.
be very high.
And the reverse
And the
bias
reverse
condition,
bias
that is the reverse
condition, that is the
saturation
reverse
current,
saturation current, is nothing but the
leakage current, which is
leakage
shown
current,
in
which
the
is
pink
shown in
color
the
here.
pink color
Okay,
here.
so this
Okay,
is for a
so this is for a
diode made up of
diode
either
made up of
silicon
either
or
silicon or
germanium.
germanium.
So if I
So
want to
if I
draw,
want to draw, if we want to
the
draw the
ideal diode
ideal diode
characteristics,
characteristics, if we want to draw the
ideal
ideal
diode
diode
graph, then how
graph,
can we
then
do
how
it?
can we do it?
An ideal
An
diode
ideal
graph,
diode graph,
considering there is no
considering there
cut
is
in
no cut in
voltage,
voltage,
we have to
we
consider
have
there
to
is no
consider there
cut
is
in
no cut
voltage.
in
We can draw
voltage.
in
We
this
can
way.
draw in this way.
We can
We
draw
can
in this
draw in
way.
this way.
For ideal
For
graph,
ideal graph,
this is going to
this
be
is going to
ID,
be ID,
and this is going to
and
be
this is going to
VD.
be VD.
How can we
How
show
can we
the
show the thing?
this is going to be
This
the
is going to
current,
be the
there is no
current. There is no
voltage,
V
there
eta.
is
That
no
is, there is
current,
no current.
there is no cut
There
in
is no
voltage,
cut in
therefore the
voltage.
current
Therefore, the current is will be
completely short
completely
circuited in
short
this
circuited
part,
in this part,
and here it
and
will be
here it
completely
will be
open
completely
circuited in
open
this
circuited
part.
in this part.
This is going to be
This is going to
ideal.
be
Ideal
ideal. Ideal
diode
means
means it
it will
will
be
be short
completely
circuited
short
in this
circuited in this
portion and
portion
open
and
circuited in
open
the other
circuited
way.
in the other
Okay,
way.
ma?
Okay,
So
ma?
that is
So that is
SC is nothing
SC
but
is nothing but
short circuit,
short
that is in the
circuit, that is in
forward
the
biased.
forward biased.
At the forward
At the
bias
forward
condition,
bias
it will be
condition,
short
it will be short
circuited,
circuited,
and when it will be
and when
open
it will be open
circuited, it will be
circuited,
in
it
the
will be
reverse
in the
biased.
reverse biased.
When the diode
When
is
the
in the
diode is
reverse
in the
bias
reverse
condition,
bias condition,
then it will
then
be open
it will be
circuit. This
open
is the
circuit. This is the
ideal diode
ideal
graph. If you
diode
take
graph. If
down,
you
it is
take
an
down, it is
ideal
an ideal
diode graph.
diode graph.
So next
So
class
next
we'll be
class
seeing
we'll be
the
seeing the
constant voltage
constant
model,
voltage model,
then
then
piecewise linear
piecewise
model. We
linear
are going to
model. We are going
derive
to
for
derive
certain
for certain
equations for half
equations
wave
for half
rectifier.
wave
We have
rectifier.
seen
We have
the
seen
working
the
principle of
working
half
principle
wave
of half wave
rectifier. We'll be
rectifier. We'll be
deriving
deriving
certain
certain
equations
equations
for the half
in
wave
for the half
rectifier
wave
in the
rectifier in the
next class.
next
Okay, Mama?
class. Okay, mama.